Okay, section 6.2 is on slopes of parallel and perpendicular lines. So we have a couple of examples here of parallel lines, and we're going to calculate the slope for each of those lines. There's two methods you can use to find slope: rise over run, using any two nice points on any given line segment, or you can use your slope formula, y2 minus y1 over x2 minus x1. Just be careful if you're using the rise over run method that you check to make sure your x and y axis are labelled using the same scale. So in this case here, our x and y axis are both labelled the same, so every block can count as one. So that means from point A, we go up to, we go 1, 2, 3, 4, 5. We'll get to another nice point on the line, so that means our slope of AB would be a rise of 2 over a run of 5. And if we check the slope of CD, I'm going to start with point C and go to this point here. That's another nice point. That would have a rise of 1, 2, 1, 2, 3, 4, 5, and a run of 5. So its slope as well would be 2 over 5. So what do you notice about the slopes of A, B, and CD? They are the same. And it says on the grid below, draw a line parallel to AB that passes through the point 4, 2. So based on our little example there, we can assume that parallel lines have the same slope. So if we draw a point through 4, 2, find that point first. 4, 2 would be right here at this point. And then the slope would have to be the same, of course, as the slopes of A, B, and CD, which are 2 over 5. So if I go up 2, 1, 2, then I have to go right 5. 1, 2, 3, 4, 5, which brings me off the grid. So perhaps I'll start at that point and go down 2, 1, 2, and then I would have to go left 5 to make it a positive slope, because a negative direction down over a negative direction for the run to the left would result in a positive slope. So down 2, and then left 5. 1, 2, 3, 4, 5. And when you connect those points, it should look parallel to AB. So we go back up and have a look at the second example. If we calculate the slope of EF using the rise over run method, we have going from F up to E, we would have a rise of 1, 2, 3, 4, 5, 6, 7. Oh, I lost my 1, 2, 3, 4, 5, 6, 7, 8, 9, I think. Or if I just check with the coordinates there. From -2 up to a height of 7 would be 9. Yep. And then the run would be from here 1, 2, 3. Looks like. But in this case, the line is sloping. Has a negative slope because it's falling as we move to the right. Or you can, as I said, if you think about the directions we went up first and then left. So that would be a positive rise over a negative run. Slope of GH. We take two nice points. Again, we can use G and H if you want, or two other nice points, but there's not much there. But this one here is nice. So you take that, it's not as much to count then. So then we have from that point to G, we have 1, 2, 3, rise, and a run of left 1, which would be -1. So that would mean a slope of -3 over 1. And both of those values, if you reduce them, you will get -3 for the slope of both of those lines. So what do we notice about the slopes again of these parallel lines? They are the same. And if we have to draw a line that's parallel to EF, but passes through the point 1, -1, we would plot our point 1, -1, and then we'd have to make sure that the slope was -3. So if I go up 3 from that point, 1, 2, 3, rise of 3, I have to go left 1. Or if I gone down 3, 1, 2, 3, that's the negative direction, I have to go right 1. And then I connect those points with a straight line. It's not looking too straight, but that's the best I can do with this pen, sorry. Okay, so basically what we should have learned from that little investigation is that parallel lines have the same slopes. Okay, so the next example shows two sets of perpendicular lines. So if we look at the slope of the first set of lines there, we have slope of AB if we use our rise over run method again, because again the scale of the x and y axis is the same. So if we use our rise over run method, A, and I think it's the same line we just had, so the slope should still be 2/5. 1, 2, and then 1, 2, 3, 4, 5. So the slope of AB is still 2/5, as it was in the last example. And this time though, CD, if I use this nice point here and C, we have a rise of 1, 2, 3, 4, 5, and a run of 2 to the left, so that would be 5 over -2. And I'm just going to do the other graph at the same time here now, before we answer the following questions. So slope of EF, if we check here, we have a line from E to F, and if I use this point here, right here, and E, we can see that there's a slope of 1, 2, 3 over 1. But again, it's negative. -3. And the slope of GH, if we go from this point again over to G, we have a rise of up 1 and over 3. So that would be a rise of 1 and a run of 3. So if we go back and answer the questions now for both sets of lines, it says, what do you notice about the slopes of AB and CD? They're opposite reciprocals, or negative reciprocals is the actual math term, but I find it easier to use the word opposite, because then you know that if one is positive, the other one's negative. Sometimes when you say negative reciprocals, people get confused, because the negative of a negative is the opposite or positive. Anyway, so it's easier sometimes if you say opposite reciprocals. So what you notice, their slopes are negative or opposite. It's probably easier to remember. Reciprocals. Same thing with EF and GH, their slopes are negative, or opposite reciprocals. So all that basically means that if one is positive, the other one is negative. And if one is, for example, 2/5, the other one would be the reciprocal of that, 5 over 2. But again, opposite signs. One would be positive, one would be negative. So basically reciprocals that one is positive, one is negative. And the last questions there in both ask you to draw a line on the first on the left here, draw a line through the point 4, 2, but perpendicular to AB. So AB, we remember, had a slope of 2/5, so that would mean we'd need to have a line that has a slope of the opposite reciprocal of that, which is -5 over 2. So if I go down 5, 1, 2, 3, 4, 5 from that point, I would have to go right 2, so that it would have a negative slope. And there would be the line. And then for on the right hand side, the question there asks you to draw a line that's perpendicular to EF but passes through the point 1, -1. So we plot that 1, 1, -1 would be right here. And EF had a slope of -3, so our perpendicular line would have to have a slope of the opposite reciprocal of that, or 1/3. So up 1 over 3. And the line would look like that. So the top of your page here just basically summarizes what we just talked about. Parallel lines have the same slope. perpendicular lines have slopes that are negative reciprocals of each other. And negative reciprocals basically is the same thing as opposite reciprocals. So let's take a look at filling out this chart here, knowing that relationship between parallel and perpendicular lines. So if we have a slope of 5/6, a line that would be parallel to that would also have a slope of 5/6, but something that's perpendicular to that would have a slope of the opposite, which is negative, and the reciprocal, which is 6/5. If the line has a slope of 3, parallel slope would be 3, and the opposite or negative reciprocal would be negative 1/3. Because keep in mind 3 is the same thing as 3/1. Any whole number can be put over 1. And negative 3/4, if the line has a slope of negative 3/4, a parallel slope would be negative 3/4. But a perpendicular slope would be the negative of that, or opposite of that, which would be positive 4/3. Negative 5, parallel slope would be exactly the same thing, negative 5. Negative 5 is the same thing as negative 5/1, so the opposite or negative reciprocal would be positive 1/5. Point 2, parallel slope would be the exact same, so that's not too hard, point 2. But when you go to the perpendicular slope, some people have trouble trying to figure out what the opposite reciprocal of point 2 is. Well, they know it would be negative, but they're not really sure what the reciprocal would be. So what I would suggest you do there is write it in a fraction form, which point 2 means 2/10, or in reduced form would be 1/5. So therefore the perpendicular slope would be the opposite or negative reciprocal of 1/5, which would be negative 5/1, or negative 5. Parallel slope for a line that has a slope of 0 would be 0. And perpendicular slope, keep in mind that 0 can be written as 0 over anything, so we'll just put it over 1. So that would mean perpendicular slope would be 1/0, which is the same thing as undefined. And that makes sense because you know that a slope of 0 means a horizontal line, and a slope of undefined means a vertical line, and horizontal and vertical lines are going to be perpendicular to each other. Parallel slope, again, if the slope is -1, then the parallel slope would be -1, and the reciprocal of -1 is +1. 1/1 is still 1. Okay, so the last question here on this page asks you to find the slope of a line that's parallel to the line through the points J and K that are given. So first thing we need to do is find the slope of JK. And we can use our slope formula, y2 minus y1 over x2 minus x1. So that will give you 4 minus 5 over 3 minus a -2, which would be -1 over 3 minus a -2 is the same thing as 3 plus 2. So therefore, a line that's parallel line would have the same slope. And the next question asks you to find the slope of a line that's perpendicular to the line. So the first thing we have to do is find the slope of the given line, MN, which if we use our formula y2 minus y1 over x2 minus x1 is going to be 1 minus a -3 over 2 minus a -4. And that's going to give you 1 plus 3 in the top, which is going to be 4, over 2 plus 4 is going to be 6. So that would be 2/3. So therefore, running out of space here, I'm just going to use this symbol for perpendicular. Looks like a set of perpendicular lines, perpendicular slope. Just might have to move that up a little tiny bit. Perpendicular slope would equal -3/2. The opposite reciprocal. Alright, example 3 gives you coordinates of a line wx and coordinates of a line yz, and it asks you to determine whether or not they're parallel, perpendicular, or neither. So the thing we need to do there to help us determine that would be to find the slope of each of those lines. So the slope of wx equals -4 minus 6, difference in the y coordinates, over 2 minus a -2, which is going to give you -10 over 4, which is going to give you -5 over 2 if you reduce it. And the slope of the other line is slope of yz, and that would equal 8. Take away 5 would be the difference in the y coordinates, over 5, take away a -4, and that's going to give you 3 over 9, which is going to give you 1/3. So based on that, we would say that the lines are neither parallel nor perpendicular, because the slopes aren't the same and they're not opposite reciprocals of each other. So, neither. I'm just going to use symbol for parallel or symbol for perpendicular rather than write that word out. Okay, so this symbol for parallel looks like parallel lines, and the symbol for perpendicular looks like a set of perpendicular lines. So it says in part B to sketch the lines on the grid to verify your answer. So if we sketch the line through the points W and X, -2, 6 is point W, and X is 2, -4. And if we connect those, and then the point -4, 5 for Y, be right here, and 5, 8, which would be over here, 5 and up 8. So when we connect those, it's actually kind of hard to tell whether or not they're parallel or perpendicular from the graph. So that's kind of more reason why to have another method than just looking at graph, because that kind of looks like they might be perpendicular, but we know that the slopes from our calculations that they aren't actually opposite reciprocals. If Wx had a -6 over 2, they would be opposite reciprocals, so they're close to being parallel, but perpendicular, but clearly not from our calculations. Question number 4, find the slope of a line that's perpendicular to the line through those points. So again, you'd have to find slope of line EF, which would be, you take the y coordinate of F, subtract the y coordinate of E, would be -1 minus 3, over the x coordinate of F, subtract the x coordinate of E, would be -4 minus 2. So that gives you -4 over -6, which is 2/3 when you reduce it, because both of those can be divided by -2. So the slope of a line that's perpendicular to EF is going to be -3 over 2. Part B for that question says the slope of AB is -4/5, and the slope of CD is W over 35, and part 1, that's supposed to be parallel line symbol right here. Okay, so you're told that they're parallel lines, so determine the value of W. Well, if that's the case, then the slope of AB should equal the slope of CD. And there's a couple of ways you can solve this. You can put them both over a common denominator and solve the equation of the numerators, or you can multiply both sides by the common denominator to get rid of the denominators, and that would give you an equation to solve. Or when it's a fraction equal to a fraction, you can always cross multiply. Now one of these fractions is negative, so make sure you put the negative in only the top or the bottom, not both. So I'm going to put it in the top. So I know that 5w is equal to negative 4 times 35. So 5w is equal to negative 140. So we just move up here. So 5w divided by 5 equals negative 140 divided by 5. So w equals negative 28. You would need w to be negative 28 in order to have a slope that was parallel, that made it parallel to line AB. So the next question asks you to find w so that those two lines are now perpendicular. So first thing we need to figure out is what slope we need. So in this case, if they're perpendicular, that would mean that CD would have to have a slope of the opposite reciprocal of AB. So we need the slope of CD to equal positive 5 over 4. So therefore this is the equation we'll be solving. W over 35 equals 5 over 4. And we'll just use the cross multiplying method again. Because you have a fraction equal to a fraction, you can do that. So that will give us 4 times w equals 5 times 35. So 4w equals 175, and then 4w equals 175. You want to get the w by itself, so you divide both sides by 4, and then you'd get w equals, this is not a real nice number, so you can just leave it as 175 over 4. It's kind of a strange answer, but you can have fractions, of course. And the last example there now tells you that ABCD is a parallelogram, and you have to prove that it's also a rectangle. And I think it's going to require a little bit more space than what's provided here, but we'll give it a shot. Okay, so in order for it to be a rectangle, that means you have to have 4 right angles in it, which means basically that all intersecting sides must be perpendicular to each other. So that's what we're going to do, show that the sides meet at right angles by showing that the intersecting sides are perpendicular. So we need to calculate the slope again of each side of the rectangle. So slope of AB would equal, and we'll just use the rise over the run method here because each axis is labeled in units of 1, so we can just quickly count rise and run. So from A to B we have a slope that would have a rise, or if I go down 2 and then go 1, 2, 3, 4, 5, 6 to the right, that would be negative 2 over 6, or negative 1/3. And then the slope of BC would be from B to C, it's down 3 and then left 1, so that would be a negative over a negative, down 3 over left 1, which results in a positive slope. So right away we can say that AB is perpendicular to BC, since the slopes are negative or opposite reciprocals. So that means there's a right angle at B. Then if we continue with the other sides, we've got slope CD, which if we calculate the rise and run from C to D, we've got up to and over 1, 2, 3, 4, 5, 6. So up to and over 6. But it's over to the left 6, so that's a negative 6, which gives you a slope of -1/3. So by the same reasoning, BC perpendicular to CD, because the slopes are negative reciprocals. I don't have enough room to write that out again. And then the last line segment, the slope of AD is from D to A is up 3 over 1, or just a slope of 3. So that means these are opposite reciprocals. So therefore, CD is perpendicular to AD. Also, since slopes of AB and AD are negative reciprocals. That doesn't look like reciprocals. It's going to abbreviate negative there. Negative reciprocals. AB is perpendicular to AD. I guess all those should really have line segments over them. So I just use a little tiny bit more space there. So, whoops. Therefore, there are right angles at A, B, C, and D, and A, B, C, D then is as a rectangle. Okay, so that's the end of that section. So there are some questions on page 349 to 351 of your text that you can try to practice these topics.